Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss variation of conductivity. Variation of conductivity and molar conductivity with concentration. Last class I have discussed measurement of resistance. In that one numericals I have discussed, and one numericals I want to discuss now. Okay, measurement of conductivity of ionic solution. Last class I have discussed, means in indirectly you can tell, you can just by the help of Wheatstone bridge you calculated R, and then after that when you came to know the R, then cell constant value you calculated, and means you got the cell constant value after knowing the value of resistance of the solution. Resistance of the solution, that solution R value calculated. Then after that, by knowing the R solution, you have calculated the cell constant value, means L upon A in first experiment. And second experiment, now cell constant you are knowing, then by using the formula that cell constant by R means resistant, that is equal to conductivity, means kappa. Kappa is equal to cell constant divided by R. Means in second experiment, now cell constant value you are knowing, and this R value of the other solution may be NaCl, MgSO4, calcium chloride, any solution, because in the beginning you have taken a standard solution KCl to know the cell constant. Now same experiment you are doing with other solution, other given solution, maybe calcium chloride, magnesium chloride, acetic acid, and particularly I can say any you can say, as for example sodium chloride. Sodium chloride you want to know the conductivity. Then now cell constant you are knowing, and by experiment you will come to know the R value of sodium chloride. Then now both value are knowing, cell constant and R. Then kappa means conductivity you can calculate very easily, because kappa is equal to cell constant divided by R. Okay. Now last class I have discussed one numericals by using this formula. Now another numericals I am going to discuss. After that I will come on the today's topic, variation of conductivity and molar conductivity with concentration. Okay. Now question I am reading, then I will this answer I will tell, I will give explanation. Okay. I will solve the numericals. First you understand the question. The electrical resistance of a column of 0.05 mole per liter NaOH solution of diameter 1 centimeter and length 50 centimeter is 5.55 into 10 to the power minus 3 ohm. Calculate the resistivity, conductivity and molar conductivity. Three things you have to calculate. First, resistivity means rho you have to calculate. Second, conductivity you have to calculate. And third, molar conductivity you have to calculate. And what is given? Then electrical resistance is given. Electrical resistance of 0.05 mole per liter NOH is given, means NOH concentration is given, and resistance is given. What is the resistance? Then 5.5 into 10 to the power 3 ohm, and this concentration is already given, 0.05 mole per liter of NOH, and diameter 1 centimeter and length 50 centimeter. Okay, one column is there. In that column, actually solution is kept. For that column has a diameter 1 centimeter and length 50 centimeter. Correct? Then in that can say column whose diameter is 1 centimeter and length is 50 centimeter. In that column, this 0.05 mole per liter NaOH solution is kept, and its resistance is 5.55 into 10 to the power 3 ohm. That's enough. They have given like this, and you have to calculate three things: resistivity, conductivity, and molar conductivity. Then now, first you can calculate these things. Volume you can first to calculate. Then volume formula, pi r square. That is not volume, area is equal to pi r square. This formula you are knowing. Then pi value is 3.14 and r value how much? Because this diameter is 1 centimeter. Then if diameter is 1 centimeter, then what will be the r value? Radius, half of this means 0.05. Then easily you can know the area, pi r square. Then 3.14 into 0.5 square. Okay, that result will come after multiplying. Result will come 0.785 centimeter square. Okay, if you want, you can calculate. You can convert in the meter square also. Then how? Centimeter you have to. If you want to calculate in meter square, then that this 10 centimeter is equal to 100 centimeter is equal to 1 meter. Then centimeter square is there. Then 100 power 2. 100 power 2 you have to divide this value, which in centimeter square you have to divide by 10 to the power 100 to the power 2 means 1,000,440. That will be down. That's why now centimeter square now converted into meter square. That is the 0.785 into 10 to the power minus 4. How minus 4 came? Now we are understanding. Down 100 into 100 was there. Correct? That's why it became upside 10 to the power minus 4. Then now area you are knowing. Okay. And length is given 50 centimeter. 50 centimeter means half meter. 50 centimeter means half meter, means 0.5 meter. Then now L value you are knowing, A value you are knowing. Correct? L value calculated 0.785 into 10 to the power minus 4 meter square. And L value is 0.5 meter. 0.5 meter. Then now easily you can calculate R value. Because relation actually you wanted to calculate rho, resistivity. Resistivity want to calculate, then formula you know, R is equal to rho into L divided by A. Then here that rho is equal to what? Cross multiplication you can do, and this you can calculate the rho value, okay, by cross multiplication, because R is equal to rho into L divided by A. Then rho is equal to what? R into A divided by L. Rho is equal to R into A divided by L. Then now all three values are knowing. R value is given 0.05 mole per liter. This thing, R value is given 5.55 into 10 to the power 3 ohm. Then you put the value of R. A value already you have calculated, 0.785 into 10 to the power minus 4 meter square, and divided by L. Then L is equal to 50 centimeter. Then now after solving you will get 87.135 ohm centimeter. Actually you have put all the values in centimeter, not in meter. If you want in meter also you can calculate. That is not a problem. Then here you now calculated this rho value, that ohm centimeter, 87.135 ohm centimeter. Okay. Then now rho value you have calculated. Then three things you have to calculate. Rho value calculated means resistivity. Then conductivity. What is the conductivity? Then conductivity you know that in inverse of rho means 1 upon rho is equal to kappa. That is the conductivity. Then kappa is equal to, means conductivity is equal to 1 upon rho, and rho value you have calculated. Then 1 upon rho value is 87.135, and you will get, after solving you will get 0.01148 this directly will get 0.01148 Simon per centimeter. Okay, conductivity now you got 0.0148 Simon per centimeter. Then now two things you have calculated. Third things, molar conductivity. Then molar conductivity, now that formula also you know. Molar conductivity means lambda m. Lambda m is equal to what? Kappa divided by C. And not kappa divided by C means conductivity divided by concentration. And upside 1000 you have to multiply. Correct? Because concentration is mole per liter. Means 1000 centimeter. That's why this 1000 you have to write upside. Then kappa into 1000 divided by C. That is the molar conductivity. Then you put all the value. Now kappa value you are knowing, into 1000 divided by C. Then concentration is given 5.5 into 10 to the power 3. Concentration is given 0.05 mole per liter. 0.05 mole per liter means per 1000 cc. That's why now we have written kappa into kappa value we have written 0.01148 into 1000 divided by concentration. Concentration is 0.05 mole per liter means 0.05 divided by 1000. That's why 1000 you have written upside. Then after putting this value you will get you can say final result. After solving you will get 229.6 Simon centimeter square per mole. Correct? And if you want to calculate in term of now you calculated in the term of centimeter square per mole. If you want to calculate in term of meter square per mole, then now meter term you have to use from the beginning. Means rho you can calculate same way, 5.5 into 10 to the power 3 ohm R value, and this already have calculated in meter square in the beginning, that is a 0.785 into 10 to the power minus 4, that is in meter square, divided by, now this was point concentration, this thing L value was this thing 50 centimeter, that you converted into meter, 0.5 meter. Then here you have put the value in meter, 0.5. Then after solving you will get 87.135 into 10 to the power minus 2 ohm meter. All things are same, only you are putting the value in meter. In the beginning you have put the value in centimeter. Now rho value you are knowing, resistivity, then like that way kappa conductivity value can get 1 upon rho. Then same way length is given, that is 100 1 centimeter. Diameter was length they have given this thing, length is 50 centimeter. Okay, then this thing kappa is equal to 1 upon rho. Then here 1 divided by rho value you have to put. Then rho value is what? 87.135 into 10 to the power minus 2. Then this minus 10 to the minus 2 is there. Then it will go upside 10 to the power 2. Means it will come 100. Then kappa is equal to 100 divided by 87.135, because it was 87.135 into 10 to the power minus 2. 10 to the power minus 2. Then you have written upside 10 to the power 2. Minus 2 became 10 to the power 2. Plus 2 again. That is the 10 to the power 2. That you can write as 100. Then 100 divided by 87.135. That is the kappa. Now in meter you got, ohm meter. Okay. Now you got kappa value. Kappa value got. Now after solving you will get 1.148 Simon per meter. That is the kappa. Okay. Simon per meter. Now this if you want to calculate third things also, molarity means molar conductivity. Then that again same formula you have to use. Molar conductivity means lambda m is equal to kappa divided by concentration. Conductivity kappa divided by C, conductivity divided by concentration. Then now kappa value already calculated in meter, 1.148 Simon per meter. Kappa value divided by concentration is given 0.05 mole per liter. Then now this you have to convert in cubic meter. Then it will be, if you multiply by 1000, then it will come 50 mole cubic meter. Okay, 0.05 into 1000, 0.05 mole per liter is there. You want to calculate mole per cubic meter. Then 0.05 into 1000, it will come 50 mole per meter. Okay, per meter. Then now per cubic meter. Then now just you put the value, kappa value and C value. Then kappa is equal to 1.148 Simon per meter. divided by concentration is 50 mole per cubic meter. After solving, it will come 229.6 into 10 to the power minus 4 Simon meter square per mole. Okay, this is the way to calculate. Or you know that what you calculated in the beginning in term of centimeter square, directly you can convert into the meter square also. Okay, because it is the this things centimeter square. Now directly by formula already I told you, if you will multiply it, then you will get 10 to the power minus 4. Now it will come, because centimeter square is there, centimeter square, then centimeter square 100 centimeters is equal to 1 meter, correct? And then centimeter square is there, then 1 upon 100 into 1 upon 100, directly you will get 10 to the power minus 4. Then you can write meter square per mole. Okay, this way also you can do conversion, then you have to not calculate all the things. But now we call part by part, you have to calculate all three, then everywhere you have to change in meter square. Whatever you want you can do anywhere. Okay, then this I have told you about the numericals. This type of numericals is asked in examination. Now I am going to discuss variation of conductivity and molar conductivity with concentration. If you will change the concentration, then how will conductivity change? That is the main things. You have to know these things, that if concentration you are changing, then how conductivity and molar conductivity will change. Okay, this you have to understand. Then here one thing I want to tell you, you know that these things, molar conductivity formula, both formula you know, conductivity means conductance formula also you know, conductance formula, that is the kappa into A divided by L. Okay, this is the conductance formula. If in this formula length is equal to 1 centimeter unity and A is equal to also unity, suppose both are unity, then it will become cubic centimeter, like that, 1 centimeter length and 1 centimeter square, suppose area, or unity, then 1 into 1, area is 1 meter square, or this length is 1 meter, like that way you can tell, or simply unity also you can tell, maybe centimeter, maybe meter, whatever, but unity means 1. Then now area is also 1, length is also 1. Then here conductivity, when length is unity, area is unity, then in this formula L and A you put, means G is equal to kappa into A divided by L. Then if you will put L and L value is equal to 1 and A is equal to 1, then in this situation G will be equal to kappa, means conductivity is equal to conduction. Conductivity is equal to conduction. If L is equal to 1 and L is equal to unity and A is equal to unity, both are unity, L is equal to unity, A is equal to unity, in that condition both will be the same. Both will be the same, means conductance and conductivity both will be the same under this condition. Then now one more thing you should understand, that if suppose area is unity, suppose area is unity and not this area. Suppose you A is the area, maybe some value, but length is 1. Length is only unity. But area may be some value, A you consider. Then what will be the total volume? Area into length. Then A may be some value, maybe 30, 50, 20, 10. Any value A may have. But if length is 1 only, if length is unity, L is equal to 1, then in that situation A is equal to B, correct? Because A into 1, that is equal to B. Very, very conceptual things I am telling you. A may be some value, but L is certainly 1. Then in that situation, area into 1, that is equal to B, correct? That's why you can write, if L is equal to 1, then A you can treat as a V, because after multiplication you will get same value. Suppose area was 50 centimeter square and length was 1 centimeter, correct? Then what you will get total volume? 50 into 1. Area into height or depth, whatever you can consider. 3 things you have to multiply: length, breadth, height. Then area means 2 things you have multiplied. Third things is 1. Then A is equal to B, you can write. Okay, this concept I told you. Now you come to the, you can say these things, many things. Then molar conductivity. You were knowing the formula. Molar conductivity is equal to kappa into A divided by L. Then now here L is equal to 1 and A is equal to, you can write in the place of A. Now you can write B, what I have given these things, explanation. For the A term you can write B, correct? Then now, and L is equal to 1, down 1, but for A you can write B also. Then now lambda m means molar conductivity is equal to kappa into B, you can write. Always you remember. Then this lambda m means molar conductivity is equal to kappa into B. Then this B, in this volume 1 mole solute is present. 1 mole solute is present. Okay, in this B 1 mole solute is present, correct? This you have to consider. Then now if you will want to dilute it, 1 mole if you keep as it is, 1 mole, so you can say 1 mole was suppose present in B liter. Okay, 1 mole was present in B. Then now if B you can say change, you can change the B and mole will suppose only 1 mole, but B is changing, volume is changing, mole is suppose 1 mole, suppose it is a common present, but now volume is changing. Then what will happen? If suppose volume you have increased, then volume increased means concentration will decrease, correct? Suppose now in the beginning it was volume was 1 liter, in that 1 mole was present. Now you have 1 liter, now you have increased to 10 liter. Now 1 mole is present in 10 liter. Then now concentration decreases. Concentration decreases because in the beginning 1 mole was present in 1 liter. Now 1 mole is present in 10 liter. Then concentration decreased. Suppose 1 mole per liter solution was there. Now you have added water and made it 10 liter. Now 1 mole is present in 10 liter. Then concentration decreases. Correct? Now here I told you concentration may be increased, may be decreased, but you can't you can say increase. Increase you can do only when solute you will add. That you have to not do. What is the solution? Only in that you have to make a change. Then only you can add the water. You can't remove the water. Correct? From the solution, solute plus solvent is mixed. How will you remove only water? Correct? That is not possible in an easy way. That things you can think. If you will heat, then only it is possible because water will vaporize, and because solid is non-volatile, it will not go in the atmosphere. Only water will go as water vapor outside. Then now mole will be the same, volume of water will decrease. In that situation concentration may increase, but that you have to not do in easy way. Then easy way only you can dilute the solution, means you can add the water. Then if you add the water, then solution will concentration will decrease. And when concentration will decrease, then how will it affect to the conductivity? Then generally you know that conductivity increases with concentration. If you will increase if concentration is more, then conductivity will be more. That you know in general way, because number of ions will be more. Suppose 1 mole per liter NaCl was there. Now you make 2 mole per liter. Then now conductivity will be double, because now 2 mole is present. If 3 mole per liter is there, volume you are not changing. Volume is only 1 mole. Same volume suppose you have taken, that time 1 mole was you have taken. Now that suppose extra 1 mole you have added. Then now in the same solution 2 mole is present. Then now conductivity will be more. Suppose 1 more mole, 3 mole you have, 2 extra mole you have added. Then now 3 mole. Then now again it will multiply. Conductivity will increase. And like that way, if this will decrease, conductivity concentration is decreasing, then conductivity will decrease. Okay? If directly proportional to concentration. If concentration increases, then conductivity will increase. If concentration decreases, conductivity will decrease. This is a general rule only for conductivity. But if you talk about the molar conductivity, then case will be different. If you talk about molar conductivity, then case will be different, because molar conductivity is related to mole per liter. That is a must. Mole per liter. Then now in this situation what will happen? 2 things you have to understand. If concentration decreases, then now in this case molar conductivity increases. Reverse case. Keep in mind, question is asked. In general way decreases, increases, but molar this things, if your concentration decreases, then this should decrease, actually conductivity should decrease, but molar conductivity actually in conductivity is okay, but molar conductivity will be reverse with decrease of concentration. This will increase, molar conductivity will increase, correct? This reverse way you keep in mind. If concentration decreases, then molar conductivity increases. First to remember. Now why it will happen, now I am telling you. Here see, concentration decreases, then concentration, how will it decrease? Then concentration will decrease if you will add more solvent, means 1 mole per liter was there, now it became 1 mole per 3 liter, per 4 liter, per 5 liter, correct? Then now actually for the conductivity, now if you have diluted, then this mole, number of moles, now we will think it is the same. Then actually what happens, that some molecules when say a concentrated solution you have taken, then you will find moles will be, suppose in 1 liter you have taken 2 mole, as for example 2 mole you have taken in 1 liter, then or you understand like that 5 mole you have taken in 1 liter, then 5 mole means their ions will be large, number of ions will be large. Avogadro number, 1 mole is equal to 6.0 to 10 to the power 23 particles, okay, maybe atom, maybe molecules, maybe ion. Then now see, moles are more, ions are more, but water is not sufficient 1 liter, because solution is concentrated. Then now all ions will be closed. I told you, just like in a small aquarium, if you will put more fishes, then it will be difficult for them to swim. Then same fish will keep in a big aquarium, more water is there and same number of fishes, then now they will swim in a relaxed way, and they will swim speedily also. Then same type of situation is here, that now if concentration will decrease, means same number of moles are there, but volume you have increased, solvent molecule increased, correct, by adding water, suppose it happens, then now they will move fast, that's why conductivity will increase. Conductivity will increase because you have concentration now, by adding the more water, now molecules are free to move, okay. Then here you will think that both are increasing. This conductivity is increasing, no doubt. Conductivity will increase, but volume is also increasing. And this conductivity is also increasing, but conductivity increases more than water, means Dilution, what you diluted, the volume actually increased, but in comparison to the volume, it is experimentally has been observed that volume in comparison to the volume, conductivity increases more. Correct? That's why finally conductivity increases, molar conductivity increases. Correct? Because in comparison to volume, conductivity increases more. Okay, both are increasing, but comparatively conductivity increases more than volume, because concentration decrease means volume increased, only then concentration will be there. Then as soon as you will increase the volume, then molecules will be free to move, then conductivity will be more. In this situation, conductivity will be more, it will increase more than volume increased. Okay, that's why finally molar conductivity increases with dilution. This important things I have told you. It is very, very conceptual, full of concept. Now I am telling you that other things that here one situation is there, limiting molar conductivity or conductivity at infinite dilution. Conductivity at infinite dilution, or you can tell limiting molar conductivity. Both are same. Only representation is there. Delta lambda m, you are writing lambda m. Lambda m, I told you lambda means just like a reverse of a v. V you are writing upside, this is open, now just reverses. Then in downward, that structure will be known as lambda. Then lambda down small m you are writing, that is the lambda m, molar conductivity. But now if only in this symbol 1 0, if you will write upside, then it will be called limit, this thing, not this thing, you can tell 0 also you can write, subscript 0 you can write. Then 0 means here, now dilution, suppose slowly and slowly you are adding water in the solution, then solution will dilute, conductivity will increase, conductivity will slowly and slowly increase. And after that what will happen? You are adding water and you are measuring the conductivity, then you will find conductivity is increasing. As you are adding water, conductivity is increasing. A time will come that after adding water, conductivity will not increase. It will become constant. Then that time it is called, conductivity is called, in that situation it is called limiting molar conductivity. Because you have diluted, but in the beginning it was increasing, after that it is not increasing, it become less, after that it become constant. Even you are adding more water, it is now not increasing. That's why this is a limitation. That's why it is called limiting molar conductivity. Also you can tell conductivity at infinite dilution, because you have added more water. Despite that, conductivity is not increasing. Now it became constant. Then for infinite dilution, sometimes infinite term is used. You know the symbol of infinite. Then that time you can write lambda and infinite symbol. In the place of m, lambda symbol, near the lambda you have written, then down m you were writing for the molar. Now in the place of M you can write infinite symbol. Infinite symbol. That is called, that is the conductivity at infinite dilution. Okay, this is asked, question is asked. Okay, then when concentration approaches zero, when concentration approaches zero, the molar conductivity is known as limiting molar conductivity. Correct? Means now conductivity was decreasing, concentration was decreasing because volume we are increasing, water you are adding, then concentration will decrease. When concentration approaches zero, then that time what was the molar conductivity? That molar conductivity is known as limiting molar conductivity and is represented by the symbol lambda m. Okay, lambda m, that I already told you. The variation in lambda m means molar conductivity with concentration is different for a strong and weak electrolyte. For a strong electrolyte, lambda m means molar conductivity of a strong electrolyte is different, and for weak electrolyte it is different. This you remember. Now I am telling you in case of a strong electrolyte. Then you know a strong electrolyte means what? That after adding in solvent, it will dissolve salt. If you have taken a strong salt, means I am telling you, it will dissolve maximum. It will dissolve maximum up to, you can consider 99%. 99% suppose it dissolves. Correct? Then it will, means dissociation will be maximum. More ions it will, after dissociation, it will convert or it will give into more ions. Number of ions will be more. As for example, NaCl, a strong salt is there. KCl, a strong salt is there. NOH, this is also a strong base, but it will give the ion. Acid also, you can say, it will give ions, HCl, HBr, Hi, NOH, all are electrolyte. Here I am talking about the electrolyte, maybe salt, maybe acid, maybe base. Then a strong acid, a strong base, a strong salt, whatever be, it will ionize maximum. Correct? Up to 99%. More than that also. 99.5, 99.4, like that way. Then that is called a strong salt. But here, if we are talking about the salt, then NaCl, KCl is the best example. Okay. Then a strong salt, and weak salt is, example is sodium acetate. Then now come first to the a strong electrolyte. Then a strong electrolyte, when it will ionize or it will dissociate, then maximum it will dissociate. But you know that maximum conductivity, now that I have told you that molar conductivity at zero concentration, it will increase slowly and slowly because already it is maximum dissolved. Then if you will add more water, then it will increase, conductivity will increase, but slowly increase. It will increase slowly because already maximum dissolved. If you will stir more and more, then little will increase, conductivity will increase little more, because again further it can decrease, it will give ions, positive, negative ions. Then obviously conductivity will increase. Then it will increase, conductivity will increase slowly, but maximum conductivity, you know, at zero concentration. At zero concentration, means maximum water you have added. Then that time it is called, that is called infinite dilution, you can tell. Then in case of a strong electrolyte, that maximum if you will consider, that is at infinite dilution, what is the conductivity, means lambda m. Suppose you have written lambda m and upside you write 0, that is showing about the maximum conductivity. Lambda m is molar conductivity at any concentration, but not at the zero concentration or at infinite dilution. Not that is the situation. Less than that. If you are writing delta m upside 0 script, then you are talking about the zero concentration, molar conductivity at zero concentration or at infinite dilution. And sometimes infinite terms symbol is used, sometimes 0. Okay, no problem, any symbol you can use. Then here one relation has been given, one equation is there, very conceptual. Actually, I told you that maximum, a strong electrolyte, it will dissolve maximum in the beginning only. But if you want to dissolve more, then more water you have to add, then it will dissolve maximum. It will be free to move. All ions will be free to move, and so more dissociation will be there. Then maximum dissociation will be, that is the lambda m 0. That is the maximum, means conductivity at zero concentration or infinite dilution. That time maximum conductivity will be there, maximum. That's why lambda m upside 0 you are writing for the maximum. But you can say this any other time, what will be the molar conductivity? Any other time, we are not talking about the 0 or maximum infinite dilution. Any other less than that, then that time what? It will be less than maximum. It will be less than maximum. That's why one formula came, lambda m, that is equal to lambda m 0, that is the maximum, minus some actually 100% it was not dissolved, something was remaining. Then how much was remaining, that you minus it, that is the any time delta m. Any time delta m means maximum, minus what was the remaining, not dissociated. Suppose 0.5% not dissociated, then that you minus it, then you will get any time 0.5% not dissociated, then conductivity will be less, little less, because 0.5 not dissociated, they are in the solid form, not dissociated into ions. That if you will deduct this you can say conductivity will decrease from the maximum, then you will get conductivity at any concentration other than 0, means that is the maximum. That's why maximum minus conductivity due to that ions which has not dissolved, as for example 0.5%, and that you minus it, then total minus this which has not dissociated, conductivity due to undissociated moles, undissociated moles, that is the, you can say, conductivity at any time. Correct? Then for that one formula is there, that is the delta m means molar, lambda m means molar conductivity is equal to molar conductivity at infinite dilution minus conductivity into, you can say, concentration. Here concentration is under root. Okay, concentration is under root. Then this is actually due to unionized. Okay, then this delta lambda m 0 minus lambda c under root c, you can tell, under root c. Okay, this is the equation. Then here you have seen, if you will draw a plot, suppose you want to know what is its maximum value. A strong salt's maximum value you want to know, means molar conductivity at infinite dilution. Then you know that salts are not fully ionizing 100%. But you want to know what is its maximum conductivity, means conductivity at infinite dilution or conductivity at zero concentration. Both are same. Then you will get only by extrapolation of plot. By plot only you can get it, not this thing. Theoretically you will get it, not practically. Because it will not dissolve completely, then how will you get? Machine will tell only that things, that how many ions are there, according to that conductivity will tell. That's why plot by graph you will determine by extrapolating, means by increasing. Then if you will plot the graph lambda m against c, under root c means c half, you can tell, under root c, you can write c half also. If concentration, if suppose you are getting some value that at this concentration this is the molar conductivity, means different concentration, different molar conductivity will be there. Then suppose experimentally you are getting many values at a different concentration, different molar conductivity value you are knowing. Then you can draw a graph. Then y-axis you can draw this things, molar conductivity, and x-axis means horizontally you can write under root c. Then under root c versus molar conductivity. If you draw the graph, means y-axis vertical, that is vertical means y-axis, there is a distance, molar conductivity, and x-axis, that is a horizontal, that you can write under root c. Then if you draw the graph, because you know the values of both at different concentration, different distance, conductivity value, molar conductivity. Then if you draw the graph, then you will find a straight line. Because only few values you will get. Then by this point, suppose 3-4 point was there, then at least 3 points should be there. Minimum 3 point is required. 4-5 is there, then no problem, not less than 3. Then if you will, by use of this 3.4 point, if you will draw line, then it will go up also, it will touch the y-axis also, and it will touch x-axis also. That line, it will, now you are increasing, then it will touch to the y-axis, it will touch to the x-axis, correct? Then this y-axis, now from 0 to where it is touching at y-axis, that is called intercept. Total length from 0 to maximum, where it is touching at y-axis, that is the intercept, and this down also. Now 0 to on x-axis you will get some value. Okay, then maximum conductivity. What is the maximum? Maximum conductivity means conductivity at 0 concentration or at infinite dilution. That what where it is, because it is already that in graph you have marked up to the maximum, minimum to maximum you are marking. That is the rule. When any graph you are drawing, then it quickly will come to know the maximum value of y where it is touching. Suppose every small square was 1 centimeter and 11 was there, then 11 into 1 11 centimeter, correct. And here x-axis, suppose it came to the 9 square, small square, then each 1 square means, suppose you have considered 1 centimeter, then 9 means 9 centimeter. Then this side 11 y-axis, and then y-axis whatever value was there, 1 centimeter square means you might have considered some conductivity, molar conductivity. Here molar conductivity maximum now you are knowing, because 1 square is equal to what value you have considered you are knowing, then maximum value you are knowing. And x-axis, that value also, because under root that value is there. Then now both values you are knowing, but here on y-axis that is the maximum, means lambda m 0 value you are knowing, maximum. Then now this side minus with root c, before root c one coefficient is there, no, lambda sign is there, only lambda, that is for undissociated, you can tell. Then that that value want to know what is the coefficient value before root c. Then lambda m 0, that value is called actually infinite conductivity at infinite dilution, that is intercept. Then that value is for maximum. And x-axis what you will tell for the x-axis, then that value you will use, actually that value you are knowing. Then now it will help you to calculate the tan theta. Then this you can say x-axis value, it will tell about conductivity due to undissociated mole, correct. Then these two value, y-axis value, x-axis value, it will be very helpful. It will be helpful to calculate the tan theta, because now it became a right angle triangle, because that's the 3-4 point what you got, you have extrapolated, you can say both side towards y-axis, towards x-axis. Then now it taken a shape of right angle triangle. Then right angle triangle means tan theta. Then tan theta is equal to what? Perpendicular divided by base. Perpendicular divided by base means h is equal to, now tan theta you are calculating, that is the perpendicular divided by base. Then perpendicular, what you got maximum value, that divided by what you got due to these things undissociated, that value means value what you got on y-axis you keep as a perpendicular, and base horizontal side what you got the value, that value. Then tan theta value you will get, tan theta. And tan theta value, whatever data will be given, easily you can calculate. 3 things you can calculate. Tan theta will be calculated. You can calculate intercepts, you can calculate, correct. Then first value y-axis value will tell about these things for maximum. Okay, you have to both you can calculate. That is the maximum you can calculate, and due to the undissociated also you can calculate. Then intercept, that is called intercept. Okay, then this I have these things I told you about the maximum value, how will you determine, and how will you calculate that tan theta. Okay, question is asked. Now next class I will discuss these things for weak electrolyte, means these things molar conductivity of weak electrolyte, and here you will get concept of Colrat's law of independent migration of ions. Okay, this I will discuss. Okay, Colrat's law, that is actually useful for this weak electrolyte. Then I will discuss this for regarding weak electrolyte in case of weak electrolyte, and then some numericals are there. I will solve it. Okay, thank you.